Right, tell me whether what about the first question? Did you discuss that question? I think only this part. Yes. What about the first question? Did we discuss it? Yes. Did we or did not? The first one?
No, sir.
Right. So tell me whether you guys just tried it or not. Then like as I'm mentioning all the time, so you are the ones who need to engage in these questions, right? Not me. I have completed these things like 4 or 5 times. So I'm not the one who is going to face the exam, right? So you guys are the ones who are going to face the exam. So you need to, as I'm mentioning all the time, you need to prepare your brain, right? So if you are not complete this one, so I'll give you few minutes, like 5 or something like that. Yeah, 5 minutes is enough, right? So this is a recent question paper, regional one from 2024, June, right? So yeah, so we'll discuss it, right? So first part, diagram one shows a generator inside a small wind turbine. The generator is connected to a lamp and the windmill blades. Okay, so here we can see there's a magnetic field given, right? Two magnets are given, and also the windmill blades are given, and the direction of rotation is also given, right? And there are some split rings and brushes, and we have also an ammeter as well, and connected to a lamp, right? So from this diagram, we can actually determine the direction of the magnetic field. So uh, before starting reading the other stuff, we'll just draw the direction of the magnetic field. So this is going to be the direction of the magnetic field, right? When the coil rotates in the direction of the arrow, the ammeter displays a small current. Explain how the generator produces the current. So 2 marks are given allocated there, right? So when the coil rotates in the direction given, the ammeter displays a small current. So ammeter displays a small current means there's a current flowing through the ammeter as well. So I don't know about the direction. So for the moment, I will say like this, right? So in order to generate a current, right? So what is the main requirement? The main requirement is that the magnetic field lines must be cut by a conducting material, right? So here the wire, so in this direction, when the mill rotates or the blades rotates, what will happen? So that is connected to this structure here. So therefore, this will be moving like this, right? And this part will be rotating in this direction. So what happens is that when the mill rotates or the blades rotate, this structure will be also rotating. So in the meantime, what will happen? The magnetic field lines will be cut, and therefore there will be an induced current, or there will be a current generation. So that is the answer, right? And part B, the generator in the wind turbine acts as an alternating current power supply. Alternating supply. So alternating means the current moves in the both directions, right? It moves in both directions, right? Then diagram 2 shows an electric circuit containing the generator being used to charge a mobile phone battery, right? So here the generator is given. So this symbol is for the AC power supply. And here you can see there's a diode given. There's a diode given, right? So, and the mobile phone battery is there. So if we are using this sort of an equipment here, right? So what is the main function of a diode, right? So now you need to revise the knowledge in electricity unit as well, right? So if we apply a diode in this direction, so it means only the current will be moving in this direction, right? So it will be acting as some sort of a valve or we can say some sort of a gate actually, right? So up to this place, what will happen? There will be an alternating current, right? Up to the diode, there will be an alternating current. But from here onwards, the current only moves in one direction like this, right? So in the other way, there won't be any current, right? So which means this mobile phone battery will be receiving a direct current, right? The mobile phone battery will be receiving a direct current. So up to this place, what will happen? You will be receiving AC, which means the current will be moving in the both direction. But from here onwards, so this is going to be acting as a one-way gate, right? One-way gate, allowing current to pass through in this direction. So therefore, what will happen? The current will be moving only in this direction, giving the mobile phone battery only the DC supply, right? Direct current is needed to charge the battery. Explain why there's a diode in the current. So the explanation I gave it in the previous case, right? So when we use a diode, what will happen? The current will be moving only for a given direction, right? Okay. Explain how the current in the battery will change if the wind speed increases. How the battery will change if the wind speed increases. So what will happen is that when the wind speed increases, so this rotation speed also increases, right? The rotation speed will be also increases, right? So what will happen? This structure here, right? This part, this section will be also moving with a higher speed, right? So this will be also rotating, will be rotating with a high speed, right? Will be rotating with a high speed. So which means, so the magnetic field lines will be cut at a higher rate. So therefore, there will be more current generated. So same theory, right? Same thing being applied in dynamo as well. But the main difference is that, so here we are rotating a coil of the conductor, but in the dynamo, we are rotating the permanent magnet around a coil, right? So try to remember those points, right? Yeah, that is the answer. The mean voltage across the battery is 7.2 volts. Okay, the battery gains 14 kilojoules of energy in 8,400 seconds. In seconds. Calculate the mean current in the battery. Calculate the mean current in the battery. Right. So what are the data points they have given? They have given a voltage value. They have given an energy value, and also they have given a time value, and they are asking the current value. So all these letters must be uh, connected with an equation, right? So you need to remember these equations actually, right? So we have the equation. The main one is energy equals voltage into charge, right? Energy equals voltage into charge. So this is the main equation. Then we know that current will be equal to charge over time. So we are going to rearrange it. So therefore, we can write the charge will be equal to I into T, right? Will be equal to current into time. So then we are going to apply that part here, right? Instead of Q. So therefore, what will we get? We will be getting an equation VIT, right? You can directly apply that equation, never mind. Or just remember the initial one, right? Just remember the initial one, then combine it and get the equation that we need to use, right? So remember, for the formulation of this sort of stuff like these equations, there might be some marks awarded, but in this case, you can see there's only 3 marks, which means the final one will be awarded for the final answer. Another one will be awarded for the correct equation, and the second mark will be awarded for the correct application of data, right? So here our equation E equals VIT. So energy 14, but given in kilojoules. So I'm going to convert that into joules. 14,000 equals voltage 7.2 multiplied by current that is to be calculated and time 8,400 seconds, right? So current value will be equal to 14,000 divided by 7.2 into 8,400. So here the answer would be 14,000 divided by 7.2 into 8,400. I'm getting an answer, something like 0.2314 amperes. Just confirm me the answer, 23148 or something like that. Yes, is it the answer?
Yes, I got the same answer.
Yeah, good, great,
Yes, sir.
good. So that is how the question concludes. So actually easy questions these are, right? So just you need to memorize the small stuff, and as I mentioned earlier, so these are regional questions, so which means like here, see, there are only like three parts, main three parts, but the final part is the only place where you have to conduct a calculation. But the other previous parts, actually, they are testing the basic theory knowledge. Like they are asking what will happen if the wind speed increases. So then a student need to have the basic theory knowledge, right? So please pay attention to those special points. They will be also tested in the exam, right? So that is how the question works. And I think question 2, we discussed it, as I can remember. And what about question 3? As I can remember, we did not, right? Yeah, so question 3. Again, most of the questions are theory related stuff. Yeah, we'll discuss this one. Question 3. A device called a metal detector can be used to find metal buried underground. Okay. Then, so they have given the structure as well. So at the end, you can see a transmitter coil and there's a receiver coil as well. So this is the place where we are holding it over here, right? So you might have seen these things in movies or something like that, right? Okay. So here the metal detector has two circuits, each containing a coil of copper wire, right? So try to use these techniques, right? So when you're like when you're engaged in a question, so underline the most important parts. So if there are like if there are some symbols to be used, then write the symbols as well, right? So in the previous case, uh, the what do you call these data points? See, I have underlined them and also I have used the standard symbols. So then easily you can connect them with each other, right? So try to use those practices, then you can maximize your marks, right? Okay, so here diagram 1 shows the circuit for the transmitter coil. Okay, so we'll just quickly go through the setup here. So the current will be moving in this direction. This is going to be the positive end. This is the negative end. So current will be moving in this direction, and here you can see the transmitter coil is in parallel with the electronics, right? It is in parallel with the electronics. Question number 1, suggest why there's a magnetic field around the transmitter coil. Suggest why there's a magnetic field around the transmitter coil. So here you can see for the electronics, they have given a power supply, right? So there will be a current going through these wires and the electronics. So therefore, there will be a magnetic field generated, right? Easy answer, right? Then part B, the cell supplies direct current. Okay. The electronics in diagram 1 change the direct current into alternating current in the coil. Describe the difference between direct current and the alternating current. So here 2 marks are allocated. You are asking the differences. So the first one, direct current having just one direction and alternating current having two directions. And another one, so if we draw the diagram, if we draw a graph here, right? So this is with the time and this is the current. So if it is just direct current, so I'll use some values as well, right? So if you take this one to be 0, and let's take this is to be +1, and here it is -1, like this, right? So if we consider, let's say, for the direct current, then it will be a line like this, right? So which means with the time, right? With the time, the current stays the same, right? So with the time, the current is same. Current is same, a constant value. So all the time you will be experiencing this, that +1 ampere, right? +1 ampere current. But if we consider the alternating current, what will happen is that, so we'll say we are starting from 0. So at the first few seconds, you will be having +1. Then it will be changed, go for the -1 part, and again move into the +1 part. So which means at a given time, so if we consider about time, so this is the 0 value, right? So then you are having 0 amperes. But here you are having +1. But if we consider a point like this, so it might be +0.5, right? And if we consider a point like this, then it can be -0.5. But if we consider here, -1. So which means in alternating current, there will be a range of current, right? There will be a range of current. So in this case, the range will be +1 to -1, right? The range will be +1 to -1. So that's why they are awarding 2 marks there, right? So first one, you need to say direct current will be having only one direction, and the alternating current will be having two directions. And the second one, you can get the direct current will be having only one value or a magnitude. But when it comes to the alternating current, there's a range of values in between a maximum value and the minimum value, right? Alternating current is applied to the transmitter coil. The diagram 2 shows a gold ring in the soil below the metal detector, right? So there's an alternating current given. So in this case, alternating current is given. Explain why there's an alternating current in the gold ring. Explain why there's an alternating current in the gold ring. Yes. Any answers that you have? Right. So I'll explain it like this, right? So we'll say, so this guy is now having alternating current. Okay. So if we consider about the lower part here, so here in this diagram, you can see it is some sort of a circular thing, right? Okay. So let's say the first situation. So this is our that lower part, which is having the circular structure, right? So at the first step, what will happen? We'll say there's a current in this direction, right? So the current is going in this direction. So if the current is going in this direction, what will happen is that there will be a magnetic field generated like this, right? There will be a magnetic field generated in this direction. So this is the first split second. And since it is having experiencing that alternating current, so the same ring, right? Now what will happen? Now the current will be moving in the other way around, like this, in this direction, in the very next split second, since it is experiencing that alternating current. So now what will happen? So if you apply that right-hand swirl rule, what will happen? Now there will be a magnetic field generated in the opposite direction, right? It is going to be generated in the opposite direction. So we'll say for the first second, you are having a magnetic field in this direction. And in the very next second, right, that will be also 1 second. So in the very next second, right, you will be having the magnetic field in the other way around, in the opposite direction. So this gold ring will be experiencing a magnetic field first in this direction in the first second, and in the next second, it will be experiencing the magnetic field in this direction, right? Did you get that point? What is the thing happening here, right?
Yes, sir.
Good. So therefore, what will happen? So here you can see a change of magnetic field direction, right? There's a direct, the change of magnetic field. So therefore, this ring will be experiencing two different magnetic fields. So depending on that situation, at a given time, there will be an alternating current in this direction, right? The current will be going in this direction. And in the very next second, the current will be moving in the other way around. Right? So that is the answer. So the thing happening here is that, so the lower end, so here we are dealing with the alternating current, right? We are dealing with the alternating current. So therefore this all the lower end, you are having two different directions of currents generating two different directions for the magnetic field. So that magnetic field will be affecting the gold ring to generate the current in different directions, actually in opposite directions. So therefore, we can say gold ring will be also having that alternating current as well, right? So those are the main points that you need to mention there, right? So actually this part is good. So the previous sections, the previous questions are actually some easy stuff, but here the last one is actually a good question that like you need to think a little bit, okay? And part C here, the diagram 3 shows the circuit for the receiver coil. So receiver coil and there's a loudspeaker. As a result of alternating current in the gold ring, there is an alternating current in the receiver coil. Explain how the alternating current in the receiver coil causes a sound to be emitted from the loudspeaker. Explain how an alternating current in the receiving coil causes a sound to be emitted from the loudspeaker. So this is actually based on the waves unit, right? So in that unit, we know how the sound is generated and also in a loudspeaker. But in the magnetism unit, we have discussed about the generation of what do you call that sound in a loudspeaker. So in that sound, in that loudspeaker, we are having that electromagnet, right? So when there's a current being generated, then the magnet will be activated and that sound cone will be moving here and there and resulting the sound particles or the wave particles to be vibrated, making a sound, right? So those are the points that you need to mention here in this question. So actually this is also based on like, direct theory parts, but as I mentioned earlier, this part, right? This question B part 2 is the most like, something like a difficult part, right? That you need to think about it. Okay. Right. Then what about this question? Question number 4. Did we discuss it? Question number 4. Yes, question number 4. Right. So for this question, for the first few parts, you can actually here you need a hard copy to measure the diameter as well. No, wait. Yeah. Mm, You guys are having the hard copy with you. Are you having the hard copy or the soft copy?
Soft copy, sir.
Okay, so then just give me a pen. I'll give you a value here. So according to that, you can calculate. Now, I'll just explain it. Then it will be easy. So once you get the hard copy, then you can try these questions, right? So here the question number one. This question is about a proton moving in a uniform magnetic field. So underline the most important part. So we are dealing with a proton and in an uniform magnetic field. Describe how to use two permanent magnets to produce an uniform magnetic field. You may draw a diagram to support your answer. So uniform magnetic field means like you need to have the parallel magnetic field lines, right? So therefore, just you can place two permanent magnets like this, having opposite ends. So then you will be having that uniform magnetic field. The diagram shows a proton moving in a circular path at constant speed in a uniform magnetic field. In a uniform magnetic field, this motion is similar to the movement of a planet in the solar system. Okay, so the direction of the movement is given. Draw an arrow to show the direction of the force on the proton. Show an arrow to show the direction of the force on the proton. So here there's nothing mentioned about the magnetic field directions. So they're just asking the centrifugal forces and the centripetal forces, right? So we'll discuss about that thing. Actually, we will be discussing about that thing in the last unit, astrophysics thing, right? So you might have heard like, so in order to keep this proton in this type of a circular path, so there will be a force acting towards the center, right? And also there's another force acting away from the center. So these two forces are equal to each other, right? So one is known as the centrifugal force and the other one is centripetal force. So the one is directing towards the center, that is known as a centrifugal force. And the other one, centripetal force, going away from the center, right? So these two forces are equal to each other. So therefore, this proton will be in the same path. Just imagine the centripetal force is higher than the centrifugal force, then the proton will be moving like this in a path like this, right? If the centrifugal force is higher than the centripetal force, then the proton will be moving like this, right? Going towards the center, right? So we'll discuss about those forces in the next few lessons. So no need of that. Accurately measure the diameter of the proton's path. So which means they are asking you to calculate the circumference of the path, right? So in order to get that value, you need to measure the radius uh, by using a ruler. Once you get the hard copy, then you can just use the 2 pi r equation to get the diameter here. And the proton completes one orbit of its circular path in a time period of this amount. Calculate the orbital speed, right? So here, this concept will be also discussed in the astrophysics section, since the equation must be like, formulated, and you need to know how to get that equation depending on the situation, right? And also, yeah, at that point, I'll again discuss this part. So here, uh, the orbital speed means the speed of this proton, right? So for the moment, I'll erase these things, right? So here, this proton is having a speed like this, right? So that is known as generally know that thing, that is the orbital speed, right? So if we need to calculate the speed, then we are using the simple equation distance over time. So the speed becomes the orbital speed, and now the distance. So here you can see the proton will be covering a distance which is equal, which is similar to the circumference of this circle, right? So the distance would be the circumference of the circle divided by time. So here, if we start at this position, so the time taken to complete, right? The time taken to complete this path and return to the initial point. So that time, that is known as the time period, right? In order to, like, in waves also, we discuss this specific section, this term. So time period means the time taken to complete a full cycle. So this is going to be the time period, right? Time period. So therefore, finally, we can write an equation V equals, so here circumference of the circle, it is going to be 2 pi r over time period. So this equation will be also, right? It will be once again discussed in the final unit, the astrophysics unit as well, right? So in that unit, we will be needing this equation to calculate the speed of satellites, or in some cases, the distance to the satellites from the surface. Likewise, there are some different applications of this equation, right? So this is the equation that we are going to use here. So in this case, there's no need of using it. So the time is given. You can apply the time period here. And 2 phi r value will be also calculated in the previous case. So you can use that value here as well, right? Then you can get the orbital speed, right? Okay. Then I think we discussed about the bicycle dynamo question, as I can remember. We discussed it. Mm, Yeah, I think as I can remember, I gave this question number 19 as a homework. And there was another question related to what do you call that, momentum. So still you are not aware of the half-life thing, so there's no need of calculating it. And we discussed about this second wire thing as well, so I can remember. Right. So question number 28. So I will give you a few more minutes. If you haven't completed, then you can give it a try, right? Yeah. So this question is from 2021, 2PR question. Question number 28. So I'll give you a few minutes, then I will start discussing it, right? I will give you 5 minutes. And if you have finished, then we'll discuss it. Okay. What about, yeah, Sabindu, Lavindu? Have you guys finished this one?
No, sir.
All right, so I'll give you a few moments. Then once after you have finished, just give me a reaction or just switch on your mics and tell me. Then we'll start discussing it, right? So this is actually a good question. Like there's a combination of theories. Like we need to think about the magnets, they are repelling and attraction or whatever the thing happening here, and also the main or the core theory part that we are focusing here is the momentum thing, right? So just give it a try. Then afterwards I'll discuss it. Okay. Yes, finished. Shall we discuss? Or need more time? Yes, shall we discuss? Or you guys need more time? Easy question. Actually, this is having a total of 8 marks, right? Which means like the maximum time that you can take is like nearly 8 minutes or something like that, right? Okay, so shall I discuss it or shall I give you a few more minutes? Then you can check your answers, ne? So once you have finished, just tell me, right? Then we can discuss it. So this is the question. We will discuss it. So try your correct your answers, right? So try to grab the techniques that I use here, right? So there can be some tricky techniques, so try to grab them. So the diagram shows an AR track. So have you seen an AR track in your physics practicals or whatever, right? So here, this one is like, we are pumping air as given in this diagram, and there are some small, tiny holes like this, and there are some gliders, right? So we can place these gliders on top of it, and because of this air supply, these gliders won't be like, touching the air track. Instead of that, they will be like, floating on them, right? So you will be having that like, like a small space in between the air track and these gliders. So since you don't have any sort of a connection or a touch between the air track and the gliders, so then there won't be any resistance value, right? Any resistance force, friction actually, right? So there won't be any friction. So in most of the conditions, there will be friction. So if there are some sort of a, like a connection between the surface and the object, then if it is moving, so definitely there will be a friction. But in this case, there's no connection, right? No touching between the surface and the object. So therefore, what will happen? We can say that the friction is minimized or friction is at a zero value, right? So we can just deal with the forces that we are applying there, right? So here, investigate the motion without friction. Air comes out through this series of small holes in the air track, which lifts the gliders slightly above the air track. There are two gliders on the track. Each glider has a magnet, right? So here, there are some data points given. So for glider A, you can see there's a data point, a value given 0.045 kilograms, but the unit is kilograms meters per second. So which is they have given the momentum value, right? So here they have given the momentum. How did I get that? Uh, I don't know whether it is mentioned in the coming questions, but by analyzing the unit here, see, kilograms meters per second, right? So that is the momentum unit. So then I can get an idea that for this direction, so and also I consider this direction to be the positive one. So therefore, the momentum is this value. So why did I mention that is to be positive? The reason is momentum equals mass into velocity, not into speed. So this is velocity, which means it is a vector, which means you need to deal with the value and the magnitude, the magnitude and the direction as well, right? Magnitude and the direction as well. So we need to consider that this is going to be the positive direction and this is going to be the negative direction. Okay, right. So here we can see glider A and glider B, and here there's a point given glider B is at rest. So which means here the velocity is zero, right? It is a stationary object, right? It is a stationary object. The poles of the magnets nearest each other are alike. They are alike. So it can be either North Pole, or it can be either South Pole, right? Explain the direction of the force acting on the magnet A from magnet B. Explain the direction of the force acting on magnet A from B, right? So since you are having two poles which are alike, then what will happen? You will be experiencing the repulsion forces, right? The repelling powers. So therefore, they are asking, explain the direction of the force acting on magnet A from B. So B, the direction will be in this direction. You need to write it as from right to left. Okay, the force direction is from right to left. The reason, so A and B both are having alike magnetic poles. So when it is when you are having a like magnetic for poles, then there will be a repulsion force. So it has to be mentioned there, the repulsion force. Then the gliders collide and the magnets cause them to rebound. Okay. Before the collision, the momentum of glider A is 0.045 to the right and the glider B is at rest. State the total momentum of glider A and B after the collision. So actually you need to be cunning with these type of questions. Since you can see here, the value is given, just one mark is allotted, right? So which means there won't be any sort of a calculation or anything at all, right? So they are asking the total momentum. So we have studied about the momentum conservation theory, right? So which means the total momentum before collision will be equal to total momentum after the collision, right? So the total momentum before the collision, so only glider A is moving, having a momentum like this, and glider B is at rest. So which means the momentum of B, which is going to be zero. This is the momentum of A. So therefore, total momentum, it is going to be 0.045 plus 0. 0 is from B, which means this value will be equal to, right, directly equal to the total momentum after the collision. So just you need to write the number here. You will be getting 1 mark there. That's all, right? After the collision, the momentum of glider A is this amount to the left, which means it is going to be a negative value. Calculate the momentum of the glider B after the collision, right? So you can use different approaches, but you will get the same answer here. So the total value was 0.045, right? And for A, it is now 0.021 minus or plus, right? The total value will be there. It is going to be PB, momentum of the glider B. it is the correct way is like you need to use the yeah, it's better to use the directions, otherwise you will be getting a different answer, right? So this 0.021 going to be a minus value, right? It is going to be a minus value. Why? The reason is, so initially they are moving towards each other, or we can say the A is moving towards B, but once after getting collided with each other, A moves in this direction and B will move in this direction. So this is a positive direction. Reason we considered that. Even in this one also, they have given from left to right is going to be a positive direction. So this is going to be a negative direction. So when we are applying the momentum value for glider A, that has to be applied as a negative value. Otherwise, you will get a different answer here. So therefore, momentum of PV or the glider B, it is going to be the total of these two. So it is going to be 0.066, right? If you apply it in the other way around, right, then it is going to be 0.045 minus 21, right? Minus 0.021. Then it would be something like 0.024. You will get a different answer. So this is the correct answer. Then 2 marks will be awarded here. And if you get this answer, then you will be getting 1 answer here, right? 1 mark there, right? So that's how the marking scheme works there, right? The time taken for glider B to change its momentum is 0.19. Calculate the average force on the glider B that causes the change in momentum. The time taken for glider B to change its momentum is this amount, right? Calculate the average force on glider B that causes this change in momentum. So force will be equal to change in momentum over time, right? Change in momentum over time. So we are considering about glider B. So initially the momentum was 0. Now the final momentum is this amount, 0.066 divided by the time 0.19. 0.19. So the value is going to be 0.066 over 0.19. The force, average force going to be 0.3473. 3473. Give the direction of the force on the glider B from glider A. Give the direction of the force on glider B from glider A. So the direction would be in this direction from the left to right, right? From left to right. It's actually a good question, right? All right, then yeah, we'll discuss this question as well, to refresh our memory with respect, like regarding these waves and all the stuff, right? So for the y direction, 1 square is equal to 0.5 volts, and for x direction, 1 square equals to 0.5 milliseconds. So it is voltage against time graph, right? Determine the period of the sound wave. Determine the period of the sound wave. So period means it is the time taken to complete a cycle. So which means the time taken to complete up to this place. So here you can see 1, 2, 3, and 4 boxes are being used there, right? So which means, so per each one, it takes 0.5 milliseconds, and we are dealing with 4 here, right? So which means the time period, it is going to be 2 milliseconds, but they are asking in seconds. So you need to convert milliseconds into seconds, right? So milliseconds into seconds means milli into seconds, you need to multiply by 10 to the power minus 3 seconds, right? Or just you need to divide it by 1000. Milliseconds into seconds, you need to divide it by 1000. Calculate the frequency of the sound wave. So you have calculated the period. So frequency equals to 1 over time period. So therefore, frequency is going to be equal to 2 over 10 to the power minus 3 seconds. So which is going to be 500 hertz, right? 500 hertz. Deduce whether the humans can hear the sound wave. So for the humans, right? So there's a range that we know. The lowest value, 20 hertz, right? Yes. What is the lowest value? And the highest value? Highest value is 20,000 hertz. Lowest is 20 hertz. So in between these two values, the range. So this is the audible range. So we are dealing with 500 hertz. So which means 500 somewhere here. So therefore we can hear this sound. Okay, we can hear this sound. The current in the loudspeaker is alternating. Give the evidence for the oscilloscope trace to support this statement. The current in the loudspeaker is alternating. They are asking any sort of an evidence from the oscilloscope trace. So here you can see, right, the y-axis, right? This axis is for the voltage. So here you can see with the time what will happen, voltage is changing, right? It is having a positive value as well as a negative value as well. So therefore, you can support that statement there. Draw a circuit symbol for an AC power supply. So the circuit symbol is something like this, okay? Having a wave-like shape. So still you can't complete this question 34 part A. From part B onwards, you can do it. Okay, so therefore I will discuss part B section. Question number 34, right? Question number 34. Turn to question number 34. Question number 34, part B. The diagram shows a fusion power station could supply the national grid to the national grid in the future, right? So there's the power station and there's a step-up transformer given to the national grid. State the main method of energy transfer from fusion power station to power station generator to the primary coil of the transformer. They're asking the energy transfer method. So here we are having nuclear reactions. Then it is being converted to electrical energy, right? Nuclear energy actually, right? Nuclear energy and being converted to electrical energy. The fusion power station could supply the input coil of the step-up transformer with a current with 28 kiloamperes at a voltage of 21 kilovolts. The output coil of the transformer has a voltage of 330 kilovolts. Assume the transformer is 100% efficient. Now you can see where the question is going, right? So they're asking you to calculate the current in the output coil. So this is going to be the I primary. This is going to be V primary. This is going to be V secondary. And this is the assumption they have given. And they are asking the current in the output coil. They are asking I secondary value. So our equation is the input. So I'll start from the beginning, right? So here power input will be equal to power output. Why? The reason is this thing, right? We are assuming that the transform is 100% efficient. So which means there won't be any sort of power wastages, right? There won't be any sort of a power wastage. So therefore we can write the input power will be equal to output power as well, right? So the input power can be written as I primary into V primary will be equal to I secondary into voltage of the secondary or the second or the output coil. So the I value, IP value, so here you can see it is asking in kiloampere. So there's no need of converting the kiloamperes into amperes or something like that, right? So this is going to be 28 kiloamperes multiplied by the voltage 21 kilovolts equals an IS value that is to be calculated multiplied by voltage 330 kilovolts. So IS value is going to be equal to 28 into 21 divided by 331. Answer will be given in kiloamperes. So the answer will be 28 into 21 divided by 331, 1.776 kiloamperes. 1.776 kiloamperes is the answer. Yes, confirm the answer. Anyone who got the answer? If there are any mistakes, so please go through the question, go through the method that I have used and get the answer. Don't just copy the answers. You need to engage in these questions, okay? Not me. And here also, yeah, we'll discuss it. Question 35, the diagram shows a step-down transformer, right? Step-down transformer, which means the voltage will be decreased in the secondary coil, right? So the primary coil, you can see there's like 160 turns, and here you can see for the secondary coil, you're just having 45 turns. Explain the operation of a step-down transformer. So you need to explain it. The reason, like there will be 4 marks awarded, right? So which means you need to mention all the things about the number of turns, like those stuff, right? Okay, so I'm not going to explain that part. State the formula linking input voltage, output voltage, and the turns of a turns ratio. So just you can write the equation. So Vs over Vp, this is going to be equal to Ns over Np, right? So the order doesn't matter. Somehow you will remember that the voltage is directly proportional to the number of turns. That is the only thing that you need to remember. It doesn't matter whether you are having the Vp value as the denominator or the Vs value, right? It doesn't matter. This is the equation. Then they are asking calculate the output voltage of the transformer. So in this case, it is the Vs value. So here it is going to be Ns over Np multiplied by the Vp value. So Ns is the secondary one, 45. And the initial one, the primary one, it had 160. And here the voltage given is 12. The voltage is 12. So the answer would be 45 divided by 160 multiplied by 12. Voltage 3.375. Yeah, it can be the answer. The reason, this is a step down transformer. So the voltage must be decreased, right? The voltage must be decreased. So just imagine you are getting something like, not for this question, just imagine you are getting a value something like 11.9. So still this is a step down transformer. The reason initial value was 12 volts. So somehow the voltage value must be decreased in the second one, right? In the secondary coil, right? So that is the main thing that you need to remember when it comes to the step down transform, right? Think we discussed about this question 37 here. Mm, yeah. What about this question? Question 44. Did you give a try? Yes. I'll give you 5 minutes. Just give it a try. Then I'll discuss it, okay? Question number 44. Okay, so the diagram shows a machine that can be used to measure the speed of fast-moving protons. So we are dealing with the protons here, the positive ones. So here you can see there's a negative plate. Okay, so the positive ion will be attracted towards the negative plate. And here there's a small slit or a hole. So from that hole, the proton enters. As soon as it enters, you can see. So initially the proton traveled in a straight line, but as soon as it enters to the magnetic field through the slit, you can see there's a change of the path of this proton, and it will be directed towards the director which is situated in the above uh, sector of the magnetic field, right? So which means, so here you can see the path is being curved towards the upper direction, right? So upward direction, so which means that there's a force being applied, okay? So here, as soon as you see these statements or these data points, so force is given and the direction path is given. So in this case, the direction is in this direction, right? The speed or the whatever the thing, right? And here you can see there's a magnetic field being also applied, right? So which means you are dealing with three factors, which is force, current, right? So here, and last week I gave you that. So for a proton, the current will be also the direction of the movement, right? So there's a current direction, and we are dealing with the magnetic field as well. So we are dealing with three factors, so which means you need to apply the Fleming's left-hand rule, right? So if we apply the Fleming's left-hand rule, right? So here you can see force in this direction and current in this direction. So thumb FBI, right? So which means eventually, so if you turn your hands and the fingers according to this diagram here, right? So you can see that the magnetic field will be going towards the paper or the plane, right? Not the magnetic field, the index finger is not pointing towards you, right? It is pointing away from you. So the magnetic field is something acting towards the plane like this, right? So already we have, like, we got the solution for this question. So that is the main thing that they're asking, right? So give a reason why the proton is attracted to the negative charge plate. So proton is a positively charged one. Negatively charged plate is negatively charged. So there will be an attraction force between the positive and negative charges. That's all. The proton accelerates at 1.9 this amount from rest to a speed of this. Show that the time taken for this acceleration is about this amount. So they are asking us to show that, right? So which means we are not going to apply this value. So there's an acceleration value, rest, starting from rest to a speed. So you have A, U, V, and also we need to deal with the time as well. So we have the equation A equals final velocity minus the initial velocity over time. So you need to get the value for time. So time will be equal to V minus U over A. So here U is 0 and the final speed 1.38 into 10 to the power 5. So here I'm not going to apply the units. The reason is all are given in the standard units. So finally I will be getting the answer in seconds. So this is to be divided by 190 into 10 to the power 11, right? So it is going to be 10 to the power minus 6 here. And you will be having 1.38 divided by 1.90. You will be having 0.726. And finally, you can write it as 7.26 into 10 to the power minus 7 seconds. You will get the answer easily. The proton passes through a hole in the negatively charged plate and enters an area where the magnetic field is. the magnetic field exerts a force on the proton as shown in the diagram. This force causes the proton to follow a circular path without change in the speed, give the direction of the magnetic field. So we have actually deduced that one, determined that one. So the direction of the magnetic field is towards the plane, or going through the paper, right? Going through the paper, but in this case, you need to be specific, right? So going through the paper, it can be like pointing towards you. The direction can be like pointing towards you, or it might be going away from you. So if you are writing like this, going through the paper, then you need to write going through the paper away from us, right? Something like that. Not pointing towards you, not coming towards you. Suggest how increasing the strength of the magnetic field will affect the proton when it is moving in the magnetic field. Suggest how increasing the strength of the magnetic field will affect the proton when it is moving in the magnetic field. So when you are increasing anything, so in this case, we are dealing with the magnetic field. So if we increase the strength of the magnetic field, what will happen? There will be a huge force applied on this particle. So final outcome would be, so there's a greater force, so therefore the path will be shorter and will be having a path like this, right? So that is the answer. So once the magnetic field value goes up, so therefore there will be a greater force, so therefore the path will be changed like this, and you can say something like the radius of the path will be minimized, right? The radius of the circular path will be minimized, or even like, the particle, the proton won't be like, you can mention about a distance as well, right? It will be dropped at a, or attracted towards the director at a smaller distance or something like that. Okay, right. So that was a good question, right? So the using of Fleming's left-hand rule. Okay. Then yeah, so many questions are given about these these transformer things. You can calculate it. Actually, easy questions are there. Just you need to use the equations. So here also the same thing, right? Yeah. Yeah, the final few questions are based on the transformers, whether it is going to be a step-up transformer or or a step-down transformer. So here another thing, the movement of wires. So when these magnetic field lines are being cut by this wire, then there will be a current generated. So therefore, you will be getting a value in this ammeter, right? So when the speed of the movement increases, the current which is going to be generated will be also increased, right? So those are the main points that you remember. Okay, there are so many questions, you can try them. And so the main thing that you need to understand from, like, by doing these questions is that, like, though we study these things under a certain topic, so here we discussed about the magnetism part, but you can see that these questions are something like a mixed one, right? So you need to deal with the theory segments from the electricity as well. And there are some sections where you need to deal with the wave sections as well. So which means, like, when it comes to the overall paper, we cannot guarantee that, like, just imagine, like, we cannot say something like the whole question will be based on a certain topic or something like that, right? So it will be a mixed one actually, right? So which means you need to be fluent in all the theory parts that we are learning here, right? So this will be the end for today's session. And so as I mentioned,